Welcome back to today's session. In the previous session, we had solved one problem on uh, balanced minimization case assignment problem, right? The problem was balanced and it was minimization case. And we straight away applied Hungarian method to solve it. Now the concern is the second type of problem. Here, the problem is minimization case only, but it is unbalanced, right? We will see how to solve this problem by converting it into balanced minimization and then applying Hungarian method, right? So shall we start off? So the type of problem that we are dealing today is unbalanced minimization assignment problem. Whenever the given problem does not contain a square matrix. What do you mean by square matrix? The number of rows is not equal to the number of columns. Then the problem is said to be unbalanced. So number of rows is not equal to number of columns. The problem is unbalanced. So what are we supposed to do? Convert it to balanced problem. If the problem is unbalanced, it has to be converted into balanced problem by adding dummy row or dummy column as needed. If the number of rows are less, then add rows or dummy rows to make it equal. If the number of columns are less, then add dummy columns to make it equal. Finally, our motto is to see to it that the number of rows and number of columns are equal. In the dummy row or dummy column, the costs have to be given. But because we are adding the dummy row or the dummy column, the cost has to be considered zero. If at all, very specifically in the problem they have specified for a particular dummy row or dummy column, this is some fixed value, then you will have to take that value. If at all nothing is given, most of the times nothing would be given, you will have to consider the cost as zero, right? So we have understood the procedure of converting unbalanced problem into a balanced problem. Now we'll see how to solve an unbalanced problem, right? So we'll take an example and we'll solve so that we understand better. So the problem given is a company has 4 machines on which 3 jobs are to be done. So how many machines are there? 4 machines. How many jobs are there? 3 jobs. So does it match? No. So therefore it is unbalanced. So I'll read out the problem again. A company has 4 machines on which 3 jobs are to be done. Each job can be assigned to one and only one machine. The cost of each job on, on each machine is given in the table below, right? We are supposed to find out the total assignment cost, TAC, for this. So because it is a cost matrix, it is minimization case, so nothing to worry about it. But the problem is unbalanced because the given matrix is not a square matrix, right? The matrix given is W, X, Y, Z are the 4 machines, A, B, C are the 3 jobs. So the cost matrix is 18, 24, 28, 32, 8, 13, 17, 18, 10, 15, 19, 22. So what we see, the given problem is minimization case, but is unbalanced. So which is less, rows or columns? Obviously, rows are less. One row is less. So as the number of rows is less, we add a dummy row called DU with cost values 0. So what happens to the problem now? So the matrix became 4 cross 4 matrix with cost values 18, 24, 28, 32, 8, 13, 17, 18, 10, 15, 19, 22, and for the dummy row 0, 0, 0, 0. So now what is the first step that we are supposed to do? Because all rows do not contain zeros, we will have to perform row reduction. Identify the minimum element of each row. The minimum elements will be 18 in the first row, 8 in the second row, 10 in the third row, and obviously in the dummy row it is 0. So now subtract it and rewrite the cost matrix. The cost matrix becomes 0, 6, 10, 14, 0, 5, 9, 10, 0, 5, 9, 12, and obviously for the dummy row it is 0, 0, 0, 0. So what we observe here is all the rows have zeros and all the columns also have zeros. So therefore there is no need for us to perform column reduction. Column reduction not needed. Straight away we can go into the assignment step. So we'll see the assignment step now. So I check column wise. First column, I find a 0. I put an assignment here. The zeros in the same column, I cross. So then I go to the second column. I check. I find a 0. I put an assignment. In the same row, I had 2 more zeros. I cross it. In the third column, I don't have zeros. So I don't get an assignment. In the fourth column, there are no zeros. So I don't get an assignment. So the assignment stops. So how many assignments we were supposed to get? 4 assignments. But how many we have got now? Only 2. So what should we do? Go with the ticking procedure. So tick the rows with no assignment. So row B gets ticked, row C gets ticked. In the ticked row, look for crossed 0. So here I have a crossed 0. Tick that particular column. So in the ticked column, wherever you have an assignment, tick the corresponding row. So row A gets ticked now. Now draw the lines. The lines are drawn from ticked column and unticked rows. Ticked column is column W, you get a vertical line. Unticked row is DU, you get a horizontal line. So how many assignments we had? 2. So how many lines did we get? 2. Our line drawing is correct. So now from the uncovered elements, identify the minimum value. The minimum uncovered element out of 6, 10, 14, 5, 9, 10, 5, 9, 12, which is the minimum element? 5. So 5 is the minimum element that has to be subtracted from all the uncovered elements and has to be added at the point of intersection. So we will see the resultant now. So after we subtract 5 from all the uncovered elements and add 5 at the point of intersection, we get 0, 1, 5, 9, 0, 0, 4, 5, 0, 0, 4, 7 at the point of intersection. Here I am adding 5. So this becomes 5, 0, 0, 0. Fine. So now check whether all rows have zeros. Yes, we have zeros. Check whether all columns have zeros. Yes, it has. So there is no need for row reduction or column reduction. Straight away go to the assignment. So when we go to the assignment, so first I'll go with column wise. First column has 3 zeros. Second column has 3 zeros. Third column has 1 zero. Fourth column has 1 zero. So which is the minimum number of zeros? So either the third column or fourth column. Column wise when I go, the first column with minimum number of zeros that I get is column Y. So I make an assignment here. Cross off the zeros in the same row. Right? Now check the number of zeros. First column has 3 zeros. Second column has 2 zeros. Fourth column does not have a zero. So minimum number of zeros is column X. So in that, the first zero I encounter, I put an assignment, cross the zeros in the same row, same column. So now in column number 1, how many zeros I have? 2 zeros are left. The first zero that I get, I make an assignment, cross off the zeros in the same column. So now how many assignments did we get? Now we have got 3 assignments. How many we were supposed to get? 4. So still we have not arrived at the answer. So go with the ticking procedure. So tick the row with no assignment. Row C gets ticked. In the ticked row, look for crossed zeros. I have column W and column X with crossed zeros. Tick those 2 columns. In the ticked column, look for an assignment. So row A gets ticked. When I look into column X, I have a assignment here. Row B gets ticked. Now after ticking, draw the lines. Draw lines from ticked columns and unticked rows. Ticked column is W, I get a vertical line. One more ticked column is X, I get a vertical line. And unticked row is DU, I get a horizontal line. How many lines we got? 3. How many assignments we have? 3. So the line drawing is correct. So out of the remaining uncovered elements, 5, 9, 4, 5, 4, 7, which is the minimum element? 4. So 4 is the minimum element that has to be subtracted from all the uncovered elements and has to be added at this point of intersection. At position 5 and at position 0, 4 has to be added, and in these places 4 has to be subtracted. So obviously I'll get 0, 1, 1, 5, 0, 0, 0, 1, 0, 0, 0, 3, 9, 4, 0, 0. Right? The resultant matrix is 0, 1, 1, 5, 0, 0, 0, 1, 0, 0, 0, 3, 9, 4, 0, 0. So this is the matrix that I have obtained after subtracting the minimum from all uncovered elements and adding at the points of intersection. Now all rows have zeros, all columns have zeros. So straight away go with the assignment step. So when we go to the assignment step, so the first column has 3 zeros, second column has 2 zeros, third column has 3 zeros, fourth column has only 1 zero. So make an assignment in the fourth column. Cross the zero in the same row. So this zero gets crossed. Now first column has 3 zeros, second column has 2 zeros, third column has 2 zeros. So coming to the second column, first zero that I encounter, I make an assignment, cross the zeros in the same row and same column. So now third column has a single zero and first column has 2 zeros. So go to the third column, make an assignment, cross off the zeros in the same row, same column. Now first column is left out with only 1 zero. Make an assignment there. So how many assignments did we get? 4 assignments. How many we were supposed to get? 4. So the problem is solved. So we will see the final solution for this. So A is assigned to W, B is assigned to X, C is assigned to Y, DU, dummy row, is assigned to Z. So write the values from the original cost matrix given. So A to W was 18, B to X was 13, C to Y was 19, DU to Z was 0. So the total assignment cost, sum of all this is 50. So the total assignment cost is rupees 50 with assignments A to W, B to X, C to Y, and machine Z is left idle because it is assigned to dummy job DU. Any doubts with this? It is very much similar to minimization case balanced problem. Only when you have an unbalanced problem, first step of converting unbalanced problem into balanced problem is what you are supposed to do. Just by adding a dummy row or dummy column, your problem becomes balanced and you can continue applying Hungarian method like you did in the previous problems. Hope you have understood. Now, time to test yourself. We'll take a problem which you will solve and post your answers in the comment section. So the problem is, find the minimum assignment cost for the following problem with 4 jobs and 5 workers. How many jobs are there? 4. How many workers? 5. So is it balanced? No. Unbalanced problem. So identify the worker who has to be left idle. The cost matrix given is 10, 11, 4, 2, 8, 7, 11, 10, 14, 2, 12, 5, 6, 9, 12, 14, 13, 15, 11, 10, 7. Right? Hope you will be able to solve the problem. Fine. So now we will wind up this session of unbalanced minimization case problem at this level. Immediately we will be following with a balanced maximization problem. Immediately this video will follow. It will be uploaded today itself. So shall we wind up for now? Thank you.